Boys, good day, girls. How are you? How are you doing? Hope you are well. Hope you're not getting too cold. Okay, so this afternoon, we carry on with our mate lesson. Okay, carrying on with our data handling lesson, what we call statistics. So yesterday we started with statistics, and then we spoke about the different concepts such as distribution and frequency, and then bus and whisker, and then we talk about the stem and leaf rather. Talk about the stem and leaf, and then we talk about the um, how to find using how to represent data using this frequency distribution table. So today we'll be looking at the measures of central tendencies. Today we'll be looking at measures of central tendencies. Before I continue, my name is Sado Jafaru. My name is Sado Jafaru, and then measure of central tendency will be what we'll be looking at this afternoon in our statistics class. So at the end of today's lesson, we need to understand how to apply solve problems relating to measures of central tendencies. So when you say measure of central tendencies, we mean mean, median, mode, range. Okay, we use the word measures of central tendency. Measures of central tendency, which refers to average. It means basically average. And then the word measure of central tendency means average. So now, so when you say average, so average is that single data that can fairly represent the rest data. Okay, so average is that single data or single number that we can use we can fairly use to represent if you have a list of data sets, within an average of it is that single number or single data that can fairly represent the rest of the data. For example, if I go to a grade 10 class, so I expect a grade 10 class to be around, I can say the average age of a grade 10 class should be 16. I can say the average grade of grade 10 class should be 16. Okay, so I can take 16 as an average. I can say the average age of a grade 10 class is 16. But doesn't mean that all the grade 10 learners are 16. We'll find some of them that are 17, some of them are 18, and some of them below 16. So I'm saying that average is that single number that can fairly represent the rest of the data. So when you say measure of central tendency, we mean the average. In measure of central tendency, we refer to the average. Okay, and then in depth, we're looking at the mean, looking at the median, the mode, and the range. Okay, right. So let's start off now. So now, first of all, start with the mean. What is mean? So we say measure of central tendency. So the mean. So the mean or average of the data, it refers to. So when we say the mean, usually in mathematics, we say the mean refers to the average refers to the mean. The average, when you say measure of central tendency, referring to average. Okay. Measures of central tendency of a data is referred to as the average. Okay. So when you say average, we'll be referring strictly to the mean, but not always the case. So the mean is not always the average, especially when there is something called an outlier. When there's an outlier, then the mean is not always the average. So we'll look at that as we go in our other slides. Okay. So starting with the mean, what do you mean the mean? So the mean or average of the data refers to, is represented with this symbol X bar. We call it what? X bar. So the mean is represented with symbol X bar. So in your calculator, you also find some part of your calculator, the X bar is written. So the symbol for mean is this X bar. So mean is represented with X bar. So what does it mean? It's the sum of the data value divided by the total number of the data. Again, mean is what? Sum of data values, the sum of the data, the word sum of the data over the number, sum of the data value divided by the total number of the value, of the data. Meaning to find the mean of the data, if you're given a list of data, you get the sum, you add them all together, divided by how many they are. We give you the mean. refers to data value. We refer to the data value as X value. So the X bar is equal to, we say, your sum of all the X values. You add all your numbers, add all your data we're given, divided by how many numbers are there. Okay, so that is mean. So we better represent it as what we call what? This sigma. This is called sigma. Sigma means what? Sum. This symbol here is called sigma. So and then it means what? Sum. Meaning sum of all the numbers. Sum of all the numbers over how many the numbers are. Okay. So this symbol, it means what? It is called sigma. S-I-G-M-A, sigma. And then what does it mean? It means sum. It means summation. It means plusing. It means addition. Meaning you add all the numbers divided by how many numbers that they are. Okay. Now, whenever the number of the data value is large and there's no extreme value and outlier, then the mean is a good measure of central tendency. So we're saying if there is no outlier in a data, if there's no outlier, so what's an outlier here? An outlier is that data, is that value, is that number that is too big or too small compared to the rest of the data. An outlier is that number or that data that is too big compared to the rest of the data. So now, if you have an outlier, then we say in the absence of an outlier, the mean is a good measure of the central tendency. The mean is a good measure of the central tendency in the absence of an outlier. But when there is an outlier, then the mean will not be a good measure of the central tendency. If there's an outlier. Okay. Now let's see how this works now. So for example, calculate the mean of the following data. Calculate the mean of the following data. We have data 1, 3, 3, 3, 3, 4, 5, 9, 9, 9 as the data. Now, how do you find the mean? To get the mean, you're saying the mean represented is what? X bar is equals to sum of all the numbers, sum of X over N. Sum of all the numbers over N. Okay, sum of all the numbers over N. Sum of all the numbers over N. Okay, so meaning you plus all the numbers together divided by how many are they? 10. So say 1 plus 3 plus 3 plus 3 plus 3 plus 4 plus 5 plus 9 plus 10 plus 9. So now to avoid repeating 3 in 4 places, so we can basically see what 3 times 4. So 1 plus 3 times 4, that means 3 into 4 places, plus 4 plus 5, plus 9 into 3 places. I mean 9 times 3. All add together over how many there are? 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divide by 10. So when you add all this together, I get 49, and then divided by 10. So 49 divided by 10 give you 4,9. So you say the average of this data is 4,9. So the average is 4,9. The mean value is 4,9. Okay. So the mean is 4,9. All right. So we go on the next example. So now, so let's say the median now. So the next one we're looking at is the median. So with the median, we're saying the median is the middlemost number. The median is the middlemost. The middlemost number when data values are written in ascending order. When you arrange your data in ascending order, the middlemost value is your median. Okay. In order to determine the correct position of the median in the data, we need a formula. Position of the median is half n plus 1, where n is the number of data value. So we this is a formula to calculate what the median, especially when you have large number of data. Especially when you have large number of data, we use this to calculate the position of the median. Again, not to calculate the median, but the position of the median. What position is the median standing? So we use the formula to calculate the position of the median. So half of what? N means total number of the data. If there are 50 data, there are like 50 data now, so that means n is 50. So half of total number of the data plus 1. So if the data set contains an odd number of value, then the median will be part of the data set. So if there are odd number of values if the data set contains odd number of values, if there are like 11 or like 23, if there are odd number of values, then the median will be part of the data set, meaning the middle one, the single middle one will be the median. The single middle one will be the median if they are odd. If there are odd number in the data, then that means there'll be only single number at the middle, and that will be the median. But and then to find the position of that, we find the position of the middle number is to say 1 plus n plus 1, 1 plus n plus 1. Okay, so it will be an integer. So 1 plus n plus 1 will be an integer if we have it as odd, meaning we're going to have a whole number. If we have if our data set contains odd number of values, then by the time we use our formula 1 plus 1 over 2 bracket n plus 1, then we will have an integer which we can now use to find the position of the median. Okay, but if the data set contains even number of values, then the median will not be part of this data set. If you have like even number of values in the data set, then the median will not be part, because we have to now add the two middlemost one and then divide by 2. You have to add the two middlemost one and then divide by 2. So 1 over 2 into n plus 1 will not be an integer. So if we have an even number, so using the formula, we're not going to get an integer. And to now do that, the median will then be the average between the two middle number sets, the middlemost number set. Okay, so basically we're saying for an odd number data, so we're going to have a single number at the middle, which will be our median. To calculate the position of the middle number, we use half n plus 1 to find a position. So because half n plus 1 will give us an integer. Integer implies what? Whole number. So with the whole number, we can find the position of the median. But if the data set contains an even number of data, we contain an even number, so we will not be using, if we use the formula half n plus 1, we will not get an integer. So in that case, what we do, we have to find the average of the two middlemost number, meaning we get the two middlemost number, we add them together and divide by 2 to give us the median. I hope you understand what I'm explaining. Now let's see an example to demonstrate that. Example 1, determine the median for the following data set. Determine the median for the following data set. We have the data set 2, 9, 5, 12, 10. What's the median? What the first thing to do? The first thing to do is to arrange them in order. Put them in ascending order. Okay, that will be the first to do. Ascending order means from the smallest to the biggest. First, rearrange them. So rearranging them, we're going to have 2, 5, 9, 10, and 12. Okay, so the first thing to do, make sure your data are in order. Now, how many data are in this data set? So we have 5 data in this data set. There are 5 data. So the median will be we use the formula half of what? 5 plus 1. 5 plus 1 will give us 6. So half into n plus 1, the position, to find the median position is half into 5 plus 1. So 5 being what? The total number of data in the data set. Okay, now 5 plus 1 is 6, so half of 6 is 3. So half is 3, that means the median is at the position number 3. It's at the third position. So we count from the beginning and then check the one at the third position. So the one at the third position is the median. Okay, so the median is the value at the third position. Okay, so now the median value is the third position, and then checking that, we'll see it was 9. So our median here is 9. Okay, so the median is therefore 9, and it's divided data to 2 equal halves. So the median divided data to 2 equal halves. So there, if you divide the data to 2 equal halves, so from the median, you're going to have half of the data on the left and then half of the data on the right. Okay, so that is the median. All right, that is the median. Okay, now determine the median of the following data sets. Now, another example to determine the median of the following data sets: 3, 9, 10, 12, 15, 18. So we need to determine the median of this data set. So now, how do you find the median of the data set? How do you get the median of the data set? You can see here the data has been arranged in ascending order. The data has already been arranged in ascending order. The data is so now to find the median. So what do? We use our formula. Our formula to find the position of the median is half 6 plus 1, and that will be half of 7. So half of 7 is 3,5. So to find the median position, we need to find the average of the two middlemost one. So we're going to divide the data into 3. We're going to have 3 on the left and 3 on the right. So from there, we can now be able to find the two middlemost ones. So the two middlemost one here will be 10 and 12. We're going to add the two together, divided by 2 will give us the median. So 10 plus 12 is 22. Then 2 divided by 2 is 11. So the median will now be 11. So the median will not be part of the number. The median will not be part of the data when we have an even number of data. So the median is 11, which is not part of it, part of the data. So because it's that number that can split the whole data set into 2 equal halves. So with 11 being here, so you can have the data divided into 3 halves from the bottom and 3 halves from the top. Okay, so again, when we have even data, the median will not be part of the data. And then to find the median, we add the two middlemost one and then divide by 2. But it's an odd number of data, so we can use our formula to find the position of the median, and then we can locate the median using the formula. Okay. All right. So we go on the next example. Consider the following data set. Determine the mean and the median. Which value is an outlier? Which measure of standard tendency is more representative of this data set? So determine the mean and the median. So we need to find the mean and the median. So and then we how to find the mean and the median, we plus all of them together. To find the mean, we add all the values together and divide by how many they are. So then say 5 plus 12 plus 7 plus 36 plus 8 plus 9 plus 7. So all divided by how many? All divided by 7. So that will give us our mean. Mean, we said it was sum of data. We add all the data divided by the number of data. So sum of the data means we plus all of them together divided by the number. How many are 7? So that gives us the mean. Then how to find the median? To find the median, what do? You need to arrange them from in ascending order. To find the median, you need to rearrange your data in ascending order. So starting from the lowest one, which is 5, then 7, then 7, then 8, then 9, then 12, then 36. So arrange them in ascending order and then try to get the middle number. How do you get the middle number? You say half, find the position of the median. Find the position of the median, you say half 7 plus 1, 7 plus 1, which is 8. So half of 8 is 4. That means the fourth one, the number at the fourth position will be our median. Okay, so we now get our mean and as well as the median. So which value is an outlier? Any value is an outlier here. We talk about outlier. Then outlier is that number, is that data that's too far, too big, or too small compared to the rest of the data. So that outlier is that number that is too big or too small when you compare to the rest. So if you're looking at this properly, you see 36 seems to be bigger than the rest of the data. So 36 is far more greater than all of them. You see 36 is an outlier. 36 is an outlier. So that is an outlier because it's bigger compared to the rest of them. Okay, now which measure of standard tendency is more representative of the data set? So because of the presence of an outlier 36, so we're saying our mean will be will be false. It will be wrong to use our mean. So the mean will not be an accurate measure of central tendency because of the presence of an outlier of 36. So the mean you're going to arrive at will be a false mean, a falsified mean. It will be increased. It will be a value that will be increased due to the outlier. So the best central tendency to use is the median. So median will be a better measure of central tendency for this data. So meaning the average that should be used for this data will be the median and not the mean. So why? Because the mean is being affected with outlier. The mean value is affected by the outlier, so the mean will not be a better measure of central tendency to use for this data set. Better we use what? The median. Okay. Right. So we think arrange the data in ascending order. We do the arrangement 5 up to 36. We add them all together, we get 84 divided by 7, get 12. That means our mean is 12. Okay, our mean is 12. So there is an odd number of values, and therefore the median will be part of this data set to find the median. So you say half of 7 plus 1, which is 8, half of 8 is 4. So that means the number at the first position is our median. So go and check now which one at the first position, 8. That means 8 is our median. So the median is 8, and we divide the data to 2 equal halves. So the 8 divided data to 2 equal halves. 3 here, 3 here. Okay. So 8 is our median. So talk about outlier, we think that 36 is an extreme value compared to the other value, and it's an outlier. So there's an outlier there, which is 36. So it's an extreme value. It's a value that is out of range when you compare them with the rest of the data. So that it is an outlier in the data set. Then C, the outlier has inflated the mean. So if the presence of an outlier will inflate the mean, it will falsify the mean. It is therefore not good value to be used as a measure of central tendency. The median is not affected by the outlier, and therefore is a better measure than mean. So the median is not affected by outlier, only the mean value inflates the outlier. So in this situation, our measure of central tendency is median. So the mean here is 12. The median is what? 8. So we're saying the mean 12 is an inflated value due to the outlier. So the median is a better average. All right. Now last one, we go to the mode now. The mode. What about the mode? Mode is that data set that its value has occurred most frequently. So mode is the data set that have the highest frequency. Mode is that data set that have the highest frequency. So if two number ties for the most frequent occurrence, then the data set has two modes and it's called bimodal. So you can have data that are bimodal. If three numbers tie for the most frequent occurrence, the data set has 3 modes and are called trimodal. So you can have what? Bimodal data, and they have trimodal data. If those data have the same occurrence, the same frequency, when they occur in the same number, in the same amount. Again, mode is the one that occurs the most in the data set. That is mode. The number that occurs the most is called the mode. The number with the highest frequency is the mode. So sometimes you have two numbers occurring the most, equally the most in the data set. So we say those two data are referred to as the mode, and the data is referred to as bimodal. So we have 3 numbers occurring in the same frequency, then we say data is trimodal. Okay. For example, and then if a data set has an outlier, the mode, like the median, may also be better indicator of the most typical value. So that means in the presence of an outlier does not affect the mode. Outlier does not affect the mode. Outlier does not affect the median. So only the mean is being inflated by outlier, or is being reduced. Only the mean is affected by outlier. So sometimes, if in the presence of an outlier, the mode could be the best measure of central tendency. For example, calculate the mode for the following data. All the mode for the following data, if you check nicely, you got one, you have how many tools there? You have 4 tools, you have how many 8 here? You have 4 8s. So we're saying the 2 and 8 are the mode. The 2 and 8 are mode because 2 occurs 4 times, 8 occurs also 4 times. So they say this data is bimodal. The data is bimodal. Okay, so there are 2 modes, 2 and 8. So this value occurs 4 times each in the data set. So the data set is therefore bimodal. Okay, right. Consider the data, another example, consider the collection of data. The age of 30 people using smartphone between the age of 15 and 60 were recorded. These are the age of 30 people using smartphones. So the stem and leaf diagram of this data set is provided. Let's say we look at stem and leaf. If you enjoy the stem and leaf for this, you're going to have this. Okay, calculate the mean for this data. How to find the mean for this data? Mean, we said you plus all your values divided by how many they are. So how many are they are 30? So you plus all of them together, 16 plus 17 plus 17 plus 17, you plus all together, and then whatever you get, you divide it by 30, and that will give you the mean. Okay, and then to determine the median, so the median we say is the middlemost one. So there are 30 of them, because there are 30, so the median will not be part of the data set. So what you need to do, you need to find the average of the 2 middlemost one. So how many data do we have here? 30. So the median will be the one in position number 15 and position number 16. So we're going to find the average of those ones in between that are in position number 15 and 16. So we're going to count now from the lowest. The stem and leaf will help you to rearrange the numbers in ascending order. So with that, you can be able to calculate your median. So the median position we're saying is the 15th and 16th position. So we're going to add the numbers at position 15 and 16, then divide by 2. So let's see which ones are in the median position of 15 and 16. So there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 28 is in position number 15. 28 is position number 16. So these are the 2 middlemost positions. So to find the median, we add the 2 together. And remember, this one is 28 because we have the 10th value here at the stem, and the leaf is the 8. So the actual number is 28. So we have 28 and 28 will be our 2 middlemost number. So we're going to add them together, divide by 2. So 28 plus 28 by 2 give us 28. That means our median is 28. Okay. And then talk about the mode. The mode, which one is the mode? The one with the highest frequency, the one that occurs the most. How many ones occur the most? So you can see here there are 28 here occurs how many times? 6 times. So we're saying 28 is our mode. Okay, 28 is our mode. Why? It has the highest frequency. And then again, remember, with using your stem and leaf, that this is not considered as 8, but the real number is 28 because the stem has 2 and these are the leaves. So you put your stem and leaves together and that will give you a number 28. So these are actually 28 in value. So we see 28 as the highest frequency, and then therefore the mode is 28. Okay. So solution. To find the mean, we add all the numbers together and then divide by 30, we get what? Our answer. And then to find the median, we say to find the median is the 15th and the 16th position. The median is the average between the 15 and the 16 value. So the 15 and 16 value are 8 and 8, which means what? 28, 28. So, and then to now find the median, you have to say 28 plus 28 divided by 2, and that gives you 28. So the mode is therefore 28. Okay. The median is 28 because 28 plus 8 give you 56. 56 divided by 2 will give you 28. That is the median. Okay. Now talk about the mode now. The mode we said is the one with the highest frequency. The most frequent occurring value is 28. Therefore, the mode is 28. Okay. Now, Another question here. The following stem and leaf diagram represent the age of 40 people who donated blood. Okay, so the total age of 40 people is what? 1,544. So the total age of all the 40 guys is 1,544. So these are the ages in represented with stem and leaf of 40 people, okay, who have donated blood. So what does this mean? That means what? The first guy, the youngest guy is 17, the next is 17, 18, 18, 19, 19. So you must be able to create the numbers. To create the numbers, we're going to use the stem as well as the leaf. Now calculate the mean, median, and mode for these data. To find the mean. What do you do? The mean is the sum of data over number of data. So meaning the sum of data has been calculated, has been given. The total age has been given as 1,544. To find the mean, you want to say how many numbers are there, how many data are there? 40. So basically our average, our mean equals to 1,544 divided by 40. And that will give you our mean. Okay, that goes our mean value. And then our median value is the middle one. The middle one, because there are 40 numbers, the middle one will be the 20th and 21st number. Because there are 40 number of data in the data set. So what you say, you need to find the average of the two middlemost number. So the two middlemost number here will be the 20th number and the 21st number, the 21 number. So divide the average of these two numbers, add them, divided by 2. So we need to keep adding, checking the numbers until we get to the 20 and the 21st. So there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 35 is on the 20th number. 35 as well is the 21st number. So the two numbers at the middle are 35, 35. Again, the numbers you get to the number by putting the stem as well as the leaf together. You're gonna have 35 and 35. So the median we get by saying 35 plus 35 divided by 2, and that will give us 35. Okay, therefore the median is 35. And then find the mode. What will be the mode? Find the mode of this data set. You're saying the mode is the one that occurs the most, and then that will be, we can see here, 35 will be the mode because 35 has the highest frequency, with frequency 1, 2, 3, 4, 5, 6, 7. With frequency 7, so 35 has the highest frequency. Okay, now, so that is our main, median, and the mode. Now, comment on the usefulness of the measure of central tendency. So now, as it stands here now, we're saying usually in the absence of an outlier, our mean is usually our most reliable measure of central tendency. So with the look of things here now, there is no particular outlier. There's no particular outlier. So we say the mean is our measure of central tendency for the data. Okay. So this is another question. It's saying research was done on family having 6 children. The table below shows the number of families in the study, which indicates the number of boys. Okay, number of boys, 0. Then number of research was shown on family having 6 children. Okay, the table below shows the number of families in the study with the indicated number of boys. Okay, so now those who have 0 number of boys, they are 1. Those who have 1 number of boys, they are 24. Those who have 2 number of boys, they are 45. Those who have 3 number of boys, they are 54. Those who have 4 number of boys, they are 50. Those who have 5 number of boys are 19. Those who have 6 number of boys are 7. Okay. Now calculate the mean, median, and mode for this data. To find the mean, so what we're going to do, we're going to say 0 multiplied by 1 plus 1 multiplied by 24 plus 2 multiplied by 45, 3 multiplied by 54, 4 multiplied by 50, 5 multiplied by 96 multiplied by 7. Okay, then we add all together, then we divide it by the total number of our frequency. Again, to find the mean in the form of table like this, we multiply these two values together. Okay, that means 1 exists in 0 times. Those who don't have boys at all, they are one of them. Only one person don't have boys at all. 24 people has only one boy. So to find the mean, you times all these two columns together, you get what we call what you refer to this as x. You refer to the first row as x, the second row as f, and then you find your f times x. You multiply these two together. 0 times 1, 1 times 24, 2 times 45, 3 times 54, 4 times 50, 5 times 19, 6 times 7. Then you plus all this together, then divide it by the total number of what your frequency is. You add up for your frequency and then divide it by what you have by when you multiply the two columns, the two rows rather. Okay, so then that will give you your mean. And for the median we said the middle one. The median is the middle number. So now how to get the median? You use your frequency. First of all, you need to find out what is the total number of everything. Total number of families that were investigated. Total number of families that were investigated. So to get the number of families that were investigated, then we need to add up all their frequencies. We add up all these numbers. You can see one family has 0 number of boys. 24 families has 1 number of boys. 45 families has number of boys. 54 families have 3 number of boys. Okay, now you add all these numbers together, and then from there you can now find the median. So to find the median, you have to find the middlemost number by dividing by 2 and find the number at the number that falls into that position. Okay, and then the mode, to find the mode in this case will be the one with the highest frequency, and in that case it will be 3. So those who have 3 are the most. Family with 3 number of boys are those with the highest. Most family have 3 number of boys. You see, the mode here is 3. So 3 number of boys is the mode. Okay, and remember the mode is not the 54, but the mode is 3. Okay, the mode is 3. All right, and they're talking about the measure of center tendency. In the absence of your outlier, then we take the mean as our average. Okay, so this is where we're going to end our class today. So this is a sort of question for us to ponder on, to practice. For example, saying the mean of 3, 4, 8, 9, and x is 7, determine the x. So you should be able to solve questions of this nature. So let's practice on them and be able to apply them. We'll stop here today and carry on tomorrow. So stay safe and be well. So this is another question for us to do as well. Okay, so see you tomorrow when we look at the measure of position. Thank you for listening and enjoy the rest of the day.